And there we are.
I think we're live. I think we're live now.
And we're live now, right? Well, it's Wednesday afternoon or Wednesday evening, depending on what part of the world you're in. And we're here. Hope you guys enjoy it. We're going to go right down the list. We got Twisted Mopar Garage, Bluff. We got Cove. We got Slant Daily Garage, number 4. Who let that guy in here? We got Schmidt, One-Eyed Cat, Frank Parks, Colleen, Clint, One-Eyed Cat, mostly all parts of Patrick there, and One-Eyed Cat. So, yeah. And we have Mr. Dallas Brown back in the house. So, today on Hardcore Tech at 8 o'clock, we are going to discuss something. And I'm going to let you guys know, since we have just a few people in here right now. Way back when, me and Mr. Wilburn said, hey, let's do some myth busting on videos. So somebody who doesn't want to be named sent me a video, and this kind of pops up every 5 or 6 years, it seems like, but ported or full manifold, which one do you put your vacuum advance to? And yeah, we'll get into that at 8 o'clock, and we'll kind of dive into that, and we'll let you know what I've found, and Dallas will let you know what he found, and we'll kind of go from there. But I do have another question that goes right to Mr. Dallas. You ready, buddy?
Sure.
And this is a quadrajet, an electronic quadrajet question. Ready? You got your thinking cap on?
Yeah, replace it with an older quadrajet. There you go.
Right. So have you been seeing that the Thunderhead 289, when he came up with that carburetor cheater, have you seen that yet?
Is that the one where he had the lawnmower carburetor on the 302 Ford?
Yeah, but he's actually selling it now. So what it is, it's basically it's a plate that you can buy this from him now, and it's got a little computer control on it, and so one side of the plate goes to like an IAC. It's an idle air control valve. The other one goes to a map sensor. So what it does is, if you're running rich, it will
lean it out.
It will lean it out and then raise the RPM. So that way it leans it out. So basically, it's called a carb cheater. So when you put a wideband into it, and it's a whole kit that you buy. So this question, I'm going to unname the guy, but he goes, I was just watching Thunderhead 289, and he got this controlled vacuum leak he is talking about, and a feedback Q-jet. I asked him if he thought a better controller would make them work well, being able to adjust in real time. I posed the same question to you. May be something you can try on the Slope 6. He wants me to give it on the Slope 6, but he also wanted to know what you thought about that. Now, have you seen it at all? Have you even...
No, I have seen some of his videos, and where it's he has essentially just it's an idle air control valve.
Yep.
Really, that allows for ideal air fuel ratio, right?
Yes, you can adjust it basically on the fly.
But the problem with ideal air fuel ratio is that's a perfect scenario at idle or under no load or under constant load, right? Mm-hmm. When you're on the road, your throttle's constantly varying, and that thing would have to adjust pretty damn quick to make it efficient. Now, on the highway, I could see it because you're under almost a constant load at, say, 2,000 RPM or whatever.
Yeah.
All it's just doing is super leaning the mixture. The the quadrajet is ideal when it comes to drivability for the street, because of the small primary barrels that are about 250, 300 CFM each, depending on what year carburetor you have. And it is probably the smallest carburetor like when it comes to primaries. Now, when you get in them secondaries, because it starts pulling in demons from hell and all kinds of stuff. It's got that awesome quadrajet thermoquad noise.
Yeah, right.
Yeah, it opens up gateways of hell. So, but that small primary always delivers optimum fuel economy. When GM had 2 barrels, you had your dual jet. You always got better mileage with a 4-barrel. Always, if you could keep your foot out of the secondary, because the primary was so small. But man, I don't know if this is the ideal scenario for this guy. I mean, he's sciencing it out as best that a backyard mechanic can. But I think longevity wise, this thing, you'll find that it'll probably what you find is that it probably is not ideal for your combination, and you'll be running super duper lean, and you might end up melting pistons and pushing out head gaskets and the whole 9 yards, just because I could see it being completely mechanical with a electronic valve in between there, and something could pretty easily go wrong. If you ever notice that the more stuff you throw at the carburetor, take an 80s carburetor for instance, the more stuff that was on there, the more failure prone they were.
Yeah.
Yeah,
Right.
and it's because you had more shit, and there was more things to go wrong. I don't think in the long run it would be very beneficial. I think up front you're going to collect all your dividends, and at the end what you're going to find is you're chasing a freaking nightmare that you can't figure out what the problem is because something isn't metered correctly, and a lot of it's going to point to that controlled vacuum leak.
I'm thinking about getting one just to try it out on the slant. I was actually looking at it, and it's how an idle air control valve really works is when they fail, they usually fail closed because they're spring loaded, right?
Right.
And the solenoid defeats it, right? So when it fails, it's going to fail so closed. So it wouldn't fail open per se and then make everything run lean.
I don't think the IAC is what's going to fail. I think it's the computer controlled quadrijet's what's going to fail.
Oh, okay.
That's what the problem was with those things. It was like, if you remember, they came out like probably, 81, somewhere around there. And by the time, if you were around in the 80s and you started picking up cars, like when I was a teenager, those things were just about everywhere, right? So you 6-7 years into the electronically controlled carburetor from GM, and you'd have all kinds of problems. Usually they'd overfuel, they'd wash the cylinders down with gasoline, and then you'd smoke your rings, and you'd make a cylinder wall that was like a mirror, right?
Yeah.
And you'd have no compression left. It'd be burning oil like mad. And I'd see that this is going to be like same kind of situation where that the improperly metered fuel is going to what bites you in the ass.
Yeah. I think what I'm going to do is, because it's a pretty inexpensive system, and I think that for the slant, because it has such a small displacement engine, and I've got a relatively large cam in it, it would need sometimes when I'm coming up to a light, when it's hot, and it's not idling up. That was the one thing I really enjoyed about the fuel injection. Did you hear? I took the fuel injection off. The fuel infection.
Yeah, you told me that.
Yeah, I know. Yeah, it's off, and it runs beautiful. Car runs great. I put the carburetor on. As soon as the first time I drove it on the freeway, right to 80 miles an hour with very little input, and it did 80 miles an hour down the road, and I was just like, oh, this is
what it was meant to be like.
This is what it was meant to be like. There was no like looking at the screen and what's it doing? Is it doing something funny? I get off the road and it starts chugging, and then I'm pulling over, resetting the computer, resetting this, resetting that. No. Yeah, it had nothing to do with that. Basically, carburetor, it went. Now, the biggest issue is that my engine, it was just too small for that system. It was just way too small. A bigger engine would work really well. So like something it was like 300 cubic inches and larger. That's an ideal system for it. But for what I have, yeah, the IAC itself is just too big. Even small changes in that thing, and that's why it would
1% operation, right?
Yeah, really, is because it would move, and it would move the RPM like 500 or 600 RPM because it was such a small increment. It was such a small engine. So, yeah, it was one of those deals. So I'm going to give it a go, though. I'm going to try it because the only thing I did notice is that with the carburetor, I'm getting off the freeway, and that thing starts to heat soak a little bit. And instead of running at 850, it's at like 700 now because it's boiling a little bit of the fuel. And I think that if I try that little air cheater thing, it could just bring the idle up a little bit when you're at the light. Because you give it a shot. I mean, it's a pretty inexpensive system, so why not? So, yeah, I'm going to give that a go. And, and this weekend, I have all the parts to do Mr. VRS on Mr. Slant 6.
Oh, you're going to try the VRS on it?
Yeah, and here's how I'm going to do it. I'm going to do it in steps. The way it came out of the box, now that's a very versatile carburetor because I saw a lot of the testing that was done on that as far as I was there watching a lot of that being done as far as the calibration, how it was being set it up, and so on and so forth. And I'm going to put it on there exactly the way it comes out of the box and drive it for a week and just see what happens.
You know how I would do that setup?
Yeah.
I would take the secondary linkage rod off, and I would get it dialed in perfectly to run on a 2-barrel.
That's exactly what I'm going to do.
And then I would split that shit in half. I really would.
Exactly what I'm going to do. I was going to put in the front, I was going to take the linkage off, and I was going to plug the power valve in the back just for right now, and then just let it be. In the very front, I was going to run, like, say, a 2.5 power valve in it, so that way it keeps all the power valve out of it until the very end, because there's a lot of times where I'm kind of going up and down some of these hills, and I'm having to give it some throttle input, because once again, small engine, making very small numbers. So sometimes to go up those hills,
yeah, you got to give it the beans, yeah.
Yeah, I got to put the beans in it. And then so that was the biggest thing with the Edelbrock, is that I had to put the lightest springs in there, so that way it wouldn't kick those, it wouldn't drop those, let those jets pop up. It would keep the vacuum, keep those things down, so it would stay in that 14.2, 13.5 range instead of going all the way to 9.
Right.
But then when the RPM came up, the air fuel mixture was great. It was like in that 12.5, even when they were popped up, because it could actually use it. So yeah, we're gonna give it a go. But
yeah, why not? What do you got to lose?
Why not?
Right?
Yeah, I'm gonna leave it just the way it is and see what will happen. And in fact, Muscle Car Solutions, he's actually here right now. He's the one that gave it to me. So. It was donated to him from Edelbrock, so he gave it to me to get this thing going. So
I'm surprised I didn't throw you one.
Why not? I got one from him, and then I'm going to run it for a while. Now I'm going to give it back to him when he actually has something.
It's probably pretty close out of the box for a 350 Chevrolet.
Oh yeah,
That's what I would assume.
Yeah, in fact, we saw the. I've said this a few times, and some people have heard me say this. I literally saw it come off of a 600 plus horsepower engine, still smoking, and we dropped it right onto a stock 350 Chevy Suburban that had manifolds on it. I mean, totally bone stock. We fired it up, it idled perfect, and we didn't touch anything, and we drove it, and we went to lunch in it and drove it all around the block. And
now,
was
is
like
the VRS perfect. A mechanical secondary carburetor like a Holley double pumper?
Yes,
okay.
It is. But the difference is the circuitry, how it works. There's so much, instead of just having, like, say, an intermediate circuit, this has a high and a low intermediate circuit. So they're infinitely tunable. Plus, all the circuits really talk to each other. And there's a lot more that goes beyond that. There's many. In fact, if you go to Muscle Car Solutions, he did a whole thing on that. If you pop that up there, Muscle Car Solutions, then he actually has a video of it, of how all the ins and outs on it, where he took it apart and crawled all over it and made a video of it, and it's pretty nice. So yeah, I'm going to be doing that this weekend, and in fact, I'm rather excited for it. I'm going to try it all weekend and see if I can just run it stock. But if the wide bands are just screaming at me because
and you don't want to wash down the cylinder walls, right?
No, I don't want to wash down the cylinder walls. But I'll try it. If it goes on there and it works, I'll drive it for a week just to see what we're getting. But I can tell you that right now, my mileage has gone back up. It's over 20. It's easily over 21 miles per gallon already, because I already know when I drive to one place and I drive back where the gauge should be, and it's back to where it used to be. Because before it was just killing it. It was getting crappy mileage. And I have the fuel pump in the tank right now for 58 pounds comes up to a regulator, and then I just have 6 pounds going over to it, and it works beautiful. And also too, one thing about that is that it's less boiling of the fuel, because there's
constantly
a lot more
circulating. Yeah, it's constantly circulating through the tank.
Yeah, so it runs a lot better. So, do we have any questions I missed? No,
I don't think so.
Not yet. Oh, hey Dallas, how is the Buick 300 mule engine coming along? Pycris Burton was wanting to know.
Well, okay. And starting in November, everything went to shit. So it's not coming along. I ordered, I don't know how many, 3 flywheels for this thing, and it all came as Chevrolet flywheels. A matter of fact, I scrapped a brand new one yesterday. I need to get a flywheel for 300 is the problem, and they are few and far between. I'm going to actually just have to bite the bullet and buy the performance one from TA Performance just so I can get this thing up and going and get it to the dyno, because I do want to do, I have all the stuff to do a stock 67 motor with a 65 4-barrel intake manifold on it. And then I'm going to pull the heads and intake manifold off, and I'm going to put a set of 64 aluminum heads on it and the 64 aluminum intake manifold. After that, then I'm going to go nutsola, and we're going to throw some 4-liter rover heads on it, and that should take it up to about 13.6 to 1 compression, because they're got the really tiny 33cc chamber or 35cc chamber, whatever it is, and it's going to push the compression way up on it, and the ports and stuff are really small, so it should be very torquey, very snappy, but not make a ton of horsepower. We'll see. The other thing I wanted to do is I have a set of 65 small chamber cast iron heads to use with the big runner intake manifold and see what kind of power that makes. And then once that's all said and done and we have numbers for everything that could be possibly mixed and matched on the combination, then it's time to throw the 350 Buick heads on there with an intake manifold that's cut down, a camshaft that is actually a 350 Buick camshaft that's been turned down to work as a 300 Buick cam. It just has a 350 Buick valve arrangement. Mm-hmm. And then we're going to throw the only intake manifold I got is a 350 Buick single plane. I was going to cut it down to fit the 300. The problem is going to be that single plane is going to pretty much make a ton of horsepower over torque. And it might be a little bit confusing because that intake manifold doesn't really work well for low-end torque, but we'll find out. I mean, the 318 Chrysler came with a single plane manifold with 2-barrel, right? So it doesn't really matter, I don't think. I think the camshaft's going to dictate the most, but we'll find out what kind of power it makes with 350 Buick heads on a 300 engine with that camshaft that's the same exact profile, just on a 350 grind, and single plane intake manifold. I'll use the same carburetor even, most likely.
Yeah. Any predictions of numbers? What do you think?
I think what we're going to find is in the 65 combination is probably going to be the best combo for that engine stock, because it's got the small chambered heads. The compression's probably going to be around 9.5 or 9.75 to 1, and then it's got that true cast iron 4-barrel intake manifold. The 64 combination with the aluminum intake manifold, even though it's aluminum and the heads are aluminum, it has heated water that heats the carburetor instead of exhaust crossover. And I think what you're going to find is that thing with the small ports, the small runner size, it's probably going to be around, it's supposed to be 355 foot-pounds of torque, but that's if I had the flat top pistons in it. It's probably going to be somewhere around 320 foot-pounds of torque and maybe 260 horsepower. I think the one that's really going to kill it the most is the 65 300 combo. It's probably going to be up around 280 to 285, maybe 290 horsepower and 350 foot-pounds of torque. When we put the 350 Buick heads on it, I'm going to cut them down. I'm going to mill them to the same chamber size as the 65 300 head. So you have something to compare it to, because it has a big open chamber because they came off the 350 Buick that has much more stroke. Yeah. So the chamber is much larger. I'm going to shrink that down to the same size as the 65 300 and then build the intake manifold off of that. I'm thinking that one's probably going to have somewhere around 300 to 320 horse. Mm-hmm. And if I had to guess on torque, I think torque is probably going to be about the same at 345, 350, but it's going to occur much higher in RPM band because the runners are so much bigger on the 350 head.
Yeah, the sonic pulse is going to make it better, yeah.
Right.
All right, well, awesome. We got those numbers, and we can go back and we can write it down, and we can see if it's right when it happens.
Yeah, well, then after that iteration, because that'll be like probably 2 or 3 years from now, but after that iteration, then it's going full-blown, I mean full race 300 with the 350 Buick heads on it, just to see what kind of numbers we can make. And I think that one's probably going to crest 600 horse.
Oh, okay.
I think so.
Awesome.
If it 2 horsepower per cube, That's not unobtainium for the regular guy.
Yeah. Well, Michael Schmidt's asking me a question. Slant 6 carb versus fuel injection versus VRS, pros, cons. Actually, I have more than that. It's not only slant 6 carb, but I've done a 1 barrel. I've done the Super 6 2 barrel. I've done a Holley 2 barrel. I did an Edelbrock 500, an Edelbrock 600. I did the throttle body. I'm back to the 600. I'm going to do the VRS. And I'm trying to get my hands on a Holley 390 CFM, one of those from the NASCAR deals.
Oh, right.
Yeah, so I can put one of those on it and see if that works any better, because those are basically square bore carburetors. So,
right.
So that could be a really small primary, and then it wouldn't really, because the 600. What's nice about it is it's only got a pump shot in the front. This is the Edelbrock version. It's got a pump shot in the front, but then it has the butterfly in the back, so it doesn't really open up until the air demand gets there, and it rarely gets up there until it's over 4,000.
Right, I was going to say it'd have to be turning some serious RPMs to do that.
Yeah, exactly, and you can really kind of feel it, too. It kind of has that whoa, and it was like, well, it's kind of like, when Honda hits VTEC, it really, nothing happens, So it's about the same with the Slant 6. Once it gets over 4,000 RPM, you're like, hold on!
Well, it doesn't have much leg left after 4,000 RPM. It maybe go 4,500 or $5,000, and that's about it.
Yeah, 5,000. I've legged it out to 5,500 just to see if I would feel anything, and 5,000 is about it for that. Now, for that camshaft and that setup, you would have to put a substantially bigger cam in it to get up to 5,500 and 6,000, just because there's no airflow through the head at that point. You can have headers on it, you can have all the manifolds you want, but just getting the air in and then getting the air out, you'd have to do some serious work on that, and that's the problem.
That's the limiting factor of the Slant 6.
Yeah, is exactly the head. And unfortunately, until someone comes out with a better head, you can spend a ton of money and you're only going to get about 180 CFM out of it. I'm at about 160 right now, 165, and that's just back cutting the valves and just cleaning up the port. And it's not worth me doing all that extra money of changing valves, cutting down valves, putting in new slots. It's just factory valves at that point. It was just easier. I can make up with camshaft. Crappy cylinder head to a point.
Yeah.
Yeah. So, but yeah, that's what I've got going with that. So that's going to be a whole, quarter mile times or eighth mile times versus miles per gallon. So I'm going to have a whole chart on everything, because I've been keeping tabs on all of it. And so far, the best mileage that I got was when I had the 204R in there, and the transmission I gave you.
Yeah.
And then and I had the Holley 2 barrel on it, the actual 350 CFM. That was the best mileage I got with so far. But with just a 3-speed and no overdrive, it's been the 904 with the low ratio gears, the lockup converter, the 7 1/4 rear end, and the 600, and that's about 24. I got 26 with the 204R, but that's all it did. Is it just went good in overdrive. It just never really had any performance. Unfortunately, I never got a chance to take it to the track.
204R, if you look at it, what it actually came behind, it normally came behind a 307 Oldsmobile. Yeah. But there is other options, because you had the turbocharged Grand National, had the 204R, but I don't know if they ever came behind the anemic 231 V6. They may have, but I'm not entirely sure, because I didn't own anything from that era of 86, 87 regular Regal. They could have had one, but I don't think so, because that 204R is made for a small cubic inch V8 to be able to spin it. But when you get to that 231, it just doesn't have enough beans, right? Now, if you're slant, and then your slant would have been the same category, that transmission would have been eating up a lot of, it actually adds a lot of rotational mass, right?
Yes.
Which eats up power to the wheels. That's where it would have been ideal if you would have had a slant. I'm going to go out on a limb here. If you were to have like an Eaton M90 supercharger on one, that would have really made a big difference on that thing, fuel economy wise, because you could have got it out on the road. It could have made the 1-2 pounds of boost that it needed to capitalize on the torque, and it would have been at low RPM.
Yeah, I did notice that I think what really killed it though was that 8 3/4. I couldn't put a 7 1/4 behind there, because the yokes, I needed a 1350 style U joints, and I couldn't find anyone to make me a drive shaft that would fit the 7 1/4. because that's what the 7 1/4s are really efficient. I mean, it's the hypoid angle's literally right in the center, so
Right.
whatever it makes, it transfers, and it's very little waste. So,
Right.
and I can feel that right now. So, Patrick's actually asked me a question here, Professor B. Are you putting boost on the slant? Eventually, yes. I'm not sure what I'm going to do. You know, we do sell those EcoBoost turbos through Edelbrock. I would like to have very small turbos on it that, you know, twin.
That would be the ideal situation, is grab 2 of those EcoBoost, because your motor's what, 3.6 inches or 3.6 liters, 3.7 liters. It'll spool up just fine, and it wouldn't even notice it. Because those turbos were sized for a 3.5 liter EcoBoost.
Yeah.
Right.
It would be perfect. And then the way that thing's set up is it has the front 3 and the rear 3 right now, so it would basically just be a boom boom.
Well, you can use your Dutras, right, and the Dutra duals, and then make a flange for them, and then bang, 2 turbos
Right
side by side. Yeah.
Yep. And that's actually what I'm looking at doing. Is I'm really looking at doing that. Is if I turbocharge it, it'll be one of those, and I want it to spool up right away, so that way I'm in the boost at like 1500 RPM.
Dude, you should grab one of those Eaton M90s off the Thunderbird Super Coupe, because it was a 230 cubic inch Ford V6, 3.8 liter. It's the ideal size. Yeah, and get the intercooler, get the turbos, or get the intercooler, get the supercharger, and then literally it is probably the simplest and easiest thing to put a freaking carburetor on, because it's got this wraparound air feed that goes to the back of the supercharger, and the discharge is out the bottom, and it wraps around at the top, and you could literally just take an adapter plate and weld to that, and then open it up, and voila, you would have a place to put a carburetor on it, right?
Yeah.
I think it'd be a really cool setup, to be honest with you. And they're cheap. Man, they're cheap. You can get one of those Eaton M90s for like, I'll bet $200.
Really?
Yeah.
Well, I'll take a look at that. But I can get those turbos for really cheap too. You know. So,
okay.
Yeah, because I work there, so you know. And the thing I
you
like
know
about
somebody
turbo,
that knows somebody.
I know somebody that knows somebody. And the thing I like about a turbo is it's essentially free horsepower, and on a Slant 6 you don't really have much to trade in to get power back. You know, because you're dealing with very low numbers to begin with.
Yeah.
Michael Schwartz asking, have you ever considered an A833 trans from a late 70s truck, 3-speed manual with a 4th overdrive to increase mileage in the quarter-mile time? Yes, I actually have. But here's the thing: is that I wanted
it. Power hog.
Yeah, I really wanted this to be. You know, I love my stick shifts. In fact, I prefer a stick shift, but I want this to be something the wife can jump in, the kids can drive later on, and most people want an automatic for a daily driver. I don't mind having a stick shift for a daily driver, but I wanted something that the whole family can eventually drive, because I got a daughter who's 13, and she's going to be 14 soon, so she's already learning how to drive around the block and so on and so forth. So, you know, I'm trying to teach her early, and she wants something like there's a 67 Dart down the way here. It's a 4-door, a Slant 6, and we might pick that up for her first car or something. I don't know, but you know.
I think in something that's low power, low weight like this, the ideal transmission for stuff like this is like a T5.
Yes, that's what I was looking at. It was like an S10, or even out of a Dodge Dakota. You know, Dodge Dakota, because I have that flange that's done now, so I can bolt this to a Slant 6, and I can put anything small block to a
that would be
6.
the ideal transmission, because it's meant for small cubic inch engines. Even V6. The parasitic loss on a T5 is like almost non-measurable, right?
Yeah,
I mean, it's when you start talking one of these A833s. Yeah, it was made for one thing and one thing only, and that was drag racing with a big block. Okay, didn't care about mass of the vehicle, didn't care about rear end gear. This thing was made for was brutal horsepower and torque, and they chew up some serious power. When you're talking like, okay, let's say it takes 20 horsepower to turn, okay, and a T5 takes 5, all right? When you have an engine that's making 180, 200 horsepower, you take, let's say, 20 horsepower away, that's 10%.
Yeah, that's
right?
a lot.
That's a shitload.
Yeah.
And you take something that has 5 horsepower, well, now you're talking a considerably less number, right? You're talking like what? 2.5%, I think is what it is.
Yeah. Well, when I get
in public.
when I get Plan Z, from Tony, that's going to be a manual transmission. I'm going to put a Dakota 5-speed out of a Dodge Dakota truck. I'm going to find one at the wrecking yard and put it in there, and that way I'm going to take that. My goal with that, did I tell you the goal on that one?
No.
Drag week, okay, but there's a caveat. It's got to be naturally aspirated, and my average has to be somewhere in the 13s. So it's got to be a 13-second car, naturally aspirated, slant 6, stick shift.
Well, imagine if you get that car and then you just take the carburetor off and throw it in the nearest dumpster, and then put something else on it. It probably is going to run great.
Well, he's taken the transmission and the engine with him, which is fine. I've got plenty of them here, so I'm not worried about that. And then I'm not. It's one of those cars too that it's already been kind of cut up, so I'm not worried about it. I'm going to still keep it, the Plan Z look, but so that way it's recognizable. But I'm going to make it a stick shift. I guarantee it. I want to make it a stick shift, just because that way, like you said, the power loss is negligible. As far as what you're going to be making, right. And that way I can really dump the clutch and just and put the beans to it. And I do have an A body 8 3/4, but I'm going to try to.
It's too big.
It's too big. I'm going to try to keep that 7 1/4 in there with the 411s on it, and just see if I can make it live. I mean.
Well, if you're doing with a stick, okay, it's going to be really hard. But I think the best thing to do is if you run a centered iron clutch that slips. Yes. And then just ease it out of the hole. And once it's moving, then you hammer down on it because it doesn't matter really at that point. Yeah. But if you can keep it from doing those hectic clutch dumps, that's what's going to puke that little 7 1/4.
Yeah, and if I run a really good, like say a twin disc clutch on that, or even something that it's going to be just fine, because if I have a line lock and I just let the clutch out so that way all the gears, the slack is up, and then I rev it up and then bam, and then let it go. There's not going to have any stored energy to get those gears going. So it's I'm not worried about that so much. And in drag week, I'll just carry an extra 7 1/4 with me, because they're pretty light. So I just throw it in the trailer.
Yeah, it's not a loadable front, right? It's
not.
Okay.
No, it's not. In fact, and it's a pain in the ass to work on, just because you almost got to spread them like a Dana 60 to get the gears in and out. It's really tight to get in. Not really. I mean, you can do it without doing that, but it's a pain in the ass. So, Rain Slide 6 with the chance of cannonballs. Did either of you guys catch David Vizard's latest YouTube video, water injection, how it can help run higher static compression and use it to greatly improve miles per gallon? I didn't watch that, but I've already known this. I've ran water injection for a little while. And I did water meth injection, and I've done all that stuff. In California, I had a big lifted truck on 35s, and I had to pass smog with it, and so I used to use the water injection on that to help with that also too, and just to get it up and over some of the hills, just because they only have 91 octane there, and sometimes it would be getting hot coming up out of those things. You would turn that on, and it would cut down the detonation and just let things clean up a little bit. Have you ever messed with water injection?
I have not. I do know that it came factory. Water and methanol injection came factory on like the 62 Oldsmobile F85 with the turbocharged 215. They used to call it, I can't remember, turbo juice or something like that. Came from the factory that way. Rocket juice, maybe.
Oh, okay.
But I've never messed with water methanol injection, and I haven't watched David Vizard's latest video. I'm going to tell you right now, I haven't watched any YouTube. Okay, just been busy crying myself to sleep. So
that sucks, man. All right, so Rain and Slide 6 with a chance of cannonballs. What about using aluminum case A33 4-speed manual center force clutch with the Slide 6? Yes, that would be great, but to find one of those things a little hard. There's a Dodge Dakota transmission I can pick up for $100 at any wrecking yard, and it's a 5-speed. So that's probably the route I'm going to go, just because they're just super inexpensive. And the bell housing for a V6 is the exact same bell housing as a small block. So that with that bell housing I have, I'll be able to bolt it right up, and then I'm just going to get the whole clutch assembly off of it. And if I think if it's a I think it's a 95. Now, don't quote me on this, but I think I looked it up. It was either 95 or 97. Started with the slave with the clutch slave cylinder. So the hydraulic clutch.
Hydraulic clutch assembly.
Yeah, hydraulic clutch assembly. So that way I can kind of look into that, because that would be kind of cool. So that way it makes it a little easier. You know. Mostly Patrick saying, guys, the Feather Duster Dart Light with the Miser truck all ran the aluminum case overdrive AA830. It wouldn't be that bad. Yes, no, I agree. It wouldn't be that bad, but to find one is hard. And
Well,
like
and here's the thing. Like, back when they were doing those, there was no T5.
Yeah.
Right? And the T5 came out just for this purpose. If you would have had a T5 come out at that time, your Feather Duster or your Dart Light would have probably got 2 to 3 miles a gallon better.
Yeah, because it's ATF transmission fluid, and it's just,
And it's rollerized, and it's half the mass, rotating mass.
yeah, it's everything. Yeah, it's everything smaller. Everything's
But
better.
the one thing that I do know is that the overdrive in that A833, when it's the overdrive model, is like 0.70, which is actually a pretty damn deep overdrive. Now the T5, I believe, is 0.67 or 0.62, which is even more overdrive.
Yeah.
But then you're talking like, if you were to weigh those transmissions side by side, a T5 you can probably put on an engine with your one hand. Okay, that thing doesn't weigh anything.
It doesn't weigh anything. Yeah, I know.
Yeah.
And when my buddy had a Ford Flathead, and we got a bell housing so we could put a T5 behind it, and we went down to the wrecking yard, picked one up, and literally I carried it out. It was one of those, and I just was like,
Yeah, they're
That was
super
easy.
light, dude. They're
Yeah.
super light. There was a question up earlier. Somebody was asking about the Borg Warner 3-speed, which is, I believe, is the T85 3-speed.
is this it right here?
Yep. I think in this case, your T5 is probably going to be the least amount. It's got the engineering behind it, and that's what it was designed for.
Yeah.
To be honest with you. But that old Borg Warner 3-speed, the only downside to that 3-speed is essentially the gear ratio. The differences, the drop is so huge in between those gears.
Yeah. And I want the 1, 2, 3, 4 to be tight. I don't care how far the overdrive is, as long as the fourth is 1-to-1. I'll deal with everything else, you know. And that
Yeah.
way, with a 411 gear and the tire on it, you know, I'll just make do with whatever it is whatever it is. But whoever goes with me on that trip, on that drag week, it's gonna suck, man. Because I know that car is gonna leak. I know that car is gonna.
Well,
It always rains.
you're talking about the what is it? What is
Plan Z.
Plan Z? Yeah. That thing just it is always been. It's always had problems. It's always had problems, and I don't know how you're going to drive that on drag week.
How's
You know how gutted that thing is. I doubt you could actually put any lights in the front end of that car. Period.
Oh, I'll get them in there. I'll get them in there because I got a whole front. Clip for the front of it. You know, header panel, and I've got buckets for lights, and I'll make the wiring system as simple as possible. Literally, it'll just be a very simple system, and then I was talking to John about this. What I'll do is the subframe connectors I'm going to put into it are going to be the ones that weld to the floor. So I'll be able to weld those, fully weld them from front to
I
back.
wouldn't even put them in, dude.
Well, I'm
That
going
thing
to.
That thing doesn't have enough nuts.
Just for
to do
structural integrity, because I've heard that there's some horror stories about that thing. So,
Nah, it's everything's drilled, but I mean, you got to remember what it is. It's a slant 6 car with at the time had an automatic, and then that little puny 7.25 inch rear end. I don't think you're going to need any subframe connectors, and any weight you add to that thing is going to make
slow
it
it down.
detrimental. Yeah, it's going to really hurt it.
because if I get into the 13s, I believe I'm going to have to at least put a 6-point in it. Isn't that the rule?
No.
Isn't it? No, not 13.
Nope. When you start dipping down the 12s, when you start sweating that 12.70,
Okay.
I think is the number.
Yeah. So
So,
I don't know. I might just put one in for safety, you know, and I don't know. I want it to at least be a little bit safe because I've never seen the car in person except for the one time that I raced it, but I never crawled all over it and looked at it. But I've heard some horror stories about
dude, she's light.
that she's light and that it was a little bit of rust happening on it. And even Tony told me that there's some rust in it. So, you know, even if I have to do some patchwork on things, you know, we'll see what I have to do.
Well, Tom Brown's asking there, will the T5 center bushing fit in the factory 60s Buick bell housings? If you get one out of an S10, I believe it's the standard GM bolt pattern even on the front. You can bolt it right up to the Buick bell housing. So I'm assuming that the input shaft, the center bushing, is probably exactly the same diameter.
Yeah, I don't know that.
I would think it is.
And Mitchell's asking, how do you guys know a do-it-yourself way of comparing transmissions for peristaltic loss? How would one measure valid quantitative differences? Okay, quantifiable differences. The only way to do it would be to either take it to the track, because remember, you're gonna have oil is going to be the biggest thing on this, because a lot of those transmissions run the gear oil, where the T5 runs an ATF, which is a much thinner fluid right off the bat. So you could essentially just take an inch-pound gauge and try it out, and then just try, take an inch-pound gauge at the back, put 10 inch-pounds of force on it, put it in first, and then turn this one, and do the same thing, and then heat it up. I mean, it would be a long test, but that would be one way to do it. Or you could just even drop them in the car and take them to the track and see what they do.
I have an even easier way.
Sure.
Okay. I've actually talked about this to somebody to determine something else, but rear end loss was what I was looking at. But there's an easy way to do this. Put your engine to the transmission, hook your transmission to a rear end housing, the whole entire rear end. Put let's say an electric motor on that, or an alternator or a generator or something like that, and then light up a board. What you want to do is get all those lights in series, so it takes more power to make those lights come on, right? So you just have, like, say, 10 of them in a row. So you put the first combination in there, you start it up, it might go to 5 lights. And then you put the next combination in there, it might go to 6 lights. The next one might go to 4 lights.
Yeah, because that'll tell you how much torque. Yeah.
Right. And it's telling you how fast it's spinning and how much power it's making. Now, would you have any justifiable numbers? No, you'd have 4 lights, 5 lights, 6 lights illuminated, right? But it would give you an idea of which one would have the largest parasitic loss and the one that had the least. Because if the engine's the same, the rear end's the same, it's the same fluid, it's the same day, and you got it at the same temperature, technically it should be, if they were the same across the board, that light would be 5 lights across the board. But
yeah, so there's actually kind of that's a great way to do it, because with one of those you would know exactly which torque it takes to put it in there, because you can calculate that by load.
Right.
Yeah. Rain slant 6 with a chance of cannonballs. For a slant 6, if you get injectors, IAC, and a wideband, O2 sensors with shorty, late and CPU.
6 widebands.
Oh, 6 widebands. Okay.
Yeah.
O2s. I'm hard. It's hard for me to read shorthand. I'm sorry.
With short latency and CPU with high gigahertz clock speed, and locate controller, CPU 1 to way between injector, O2 sensors to cut time to command. You could invalid control cylinders per rev. You could control each individual cylinder, but I don't think you need all that much crap. I think like Holly EFI and the port injection intake manifold, you can control each individual injector pulse length, and you can fat each cylinder.
What he's talking about, so how it's firing. I can tell you right now that I can usually see on my widebands, they're actually fast enough now. So I have the front 3 go to 1, the back 3 go to 1 before they come together. You can actually see good down, good down. If the one's down, then you can just go and say, oh, my valve is out of adjustment before it even went. You adjust it, and then it's actually switching correctly, and you can actually see that they're fast enough nowadays at idle to catch that.
Huh.
So I personally wouldn't go through all that work, but eventually I'm going to be doing all this. That's where this thing is all going to. Is I want to exhaust all my carburetor options first, and then I'm going to go to a multi-port fuel injection, and then after that, then I'll put the turbos on it. But yeah, that's going to be the way to go. But I want to put the A500 tranny behind it with the carburetor and see what I could do, because I like carburetors at heart, because I understand them and they work really well. And you tune them right, they'll get pretty damn close. And my goal was 30 miles to the gallon at freeway speeds with this car. So I'm still working towards that. I haven't hit it yet, but I'm really working towards it. And I think the A500 is basically just a 904 with an overdrive on the back of it. So as far as parasitic loss, you're not going to lose much. And because of that, my drive shaft will work. I will just have to have it cut down and shortened, so that way I can still use my 7 1/4 rear end. And that's the key, I think, to this, is running that 7 1/4.
And the narrowest, lightest tires you can get with the light wheel. What did that A500 come in? Dakota pickups with a 6-cylinder with like a 3.9?
Yeah, exactly. And also a lot of the V8s too. I actually got one. I think it's the 93, 94, 95 were one of the best years to get, because it was an electronically switched, but it was still hydraulically controlled. So that way it still went. There was still a signal that went to the carburetor, so that would actuate how much power would it. But then it just had 3 wires going into it, so you would turn on your overdrive, and you would turn on your
converter.
And lock up a converter. So that's the one that I got, and that's the one I'm building for it. And it still has the low ratio first and second, and it's got the extra clutches in it, which is the better one to have. And so I'm actually looking forward to it. So that is going to be going in my Green Dart soon. That's probably going to be in there, hopefully before No Names. So No Name Nationals. Yeah. See, mostly our parts pretty good.
I don't see any other questions.
No.
Oh, there's not a lot of questions tonight
on
Tech Talk, surprisingly.
Right.
Yeah.
Right. Yeah. But very rare Ford. Yeah. So anything going on? Is that, I got to tell you, I was thinking about your Thunderbird the other day.
Oh yeah.
Making running. Gonna work on it.
Yeah, I'm gonna get it out.
Good.
I'm gonna get it out, get it running, get it sold.
Yeah, but at least you're gonna get it out and get it running, right?
Yeah, I'm probably gonna do the hairiest burnout that anybody's ever seen on the internet.
That's awesome.
Because this thing is, I used to call it the not fucking around T-Bird, right? Like the not fucking around car. Because I mean, this thing is, I never had 650 horse at the touch of a throttle. It was just all motor before. And when I got that thing and I got it running and I drove it around the storage unit, which I built it in, and I have it in first, and you just freaking goose it, and it would just blow the tires clean off. And I mean, it would just jump the car right off the ground and blow the tires off.
Mm-hmm. Yeah. No, I remember my first time driving something over, 500 horse NA, and it was the same type of deal. Like, whoa, like that was that was something.
I mean, I had something like that. I had a nitrous. It was a small block Ford, but I'm making about 400 horse, and I put about 200 shot of nitrous on it.
But that's different.
It wasn't the same as this.
It's not. No, because you're hitting a button and you're expecting it. When that thing, as soon as you touch the throttle on NA, it's all of a sudden all the beans are there. You're like, whoa, that's insane. Yeah. No, I got it. Patrick's asking, have you ever thought about using Mopar TBI on the slant? No, I haven't. I don't even want to go down that way. I wanted something that was really easily bolted on and then bolted off, so that way I'd have to change a bunch of stuff just to switch it out. I wanted something that would just bolt right onto what I had. If it does, maybe I'll try it, but for what I'm doing, I wanted something I could put on there, leave it on for 6 months or whatever, and then take it right back off, so that way if I didn't like it, which I didn't, it comes off in an afternoon, is exactly what I did. And I put all the rest of the parts in the box, and they're going to go to Mr. Dallas Brown.
I'm going to try that Suburban. But I think I got my quadrijet. I think I got my quadrijet dialed in, man. I've worked on it for a long time now, and it's pretty damn dialed in to where it's got to be pretty damn close to 16, 17 miles a gallon to get on the interstate. Mm-hmm. Tom Brown's asking a question down there. It says, what was the small rear axle that came in the Vega, Skyhawk, Monza? Good mileage rear axle. That's the 7 1/4 or a 7.5 inch GM.
What's the GM?
10 bolt. It's what everybody confuses it because it's got a 10 bolt cover and it's a 10 bolt. This thing is so freaking spindly.
It's like a 7 1/4.
Yeah, we put a stock 350 Buick in there and it would spit the freaking ring gear right out the back.
Yeah.
They're just so spindly. But that's the same rear end that was used in, like, say, a 2002 Camaro with an LS.
Yeah. Yeah. Same with the 7.25. I mean, they take abuse. We've abused them, but when they
Oh, they're
blow,
not
they blow
happy.
good.
Yeah, I had a 7.5 inch in a Regal. It came with 342 gears, and I raced on it for a couple of seasons with slicks on it, and I blew it up I think twice that one season, and it wasn't all that bad. I ended up just going to a Richmond gear, which actually solved it, spitting teeth right out the back. The problem was when I went to take it apart for the last time, that pin in the center that holds the axles in, because it still had C-clip axles, that pin was S-shaped, and you could not get it out.
Yeah.
You literally had to cut that thing. And I'll tell you right now, there ain't a tool that you own that could cut that and get in there to it, right? I mean, it is literally harder than a coffin nail. And the Sawzall is nothing. I mean, it'll just chew the teeth right off the blade. Yeah.
Didn't even scratch it. Yeah. Smith is actually he's asking a good question here. Anybody go through the learning process to run nitro on the street car periodically at the drags? Have you ever done this? I know
Nitro?
I have. Yeah, nitromethane.
No, I've never messed with nitro ever.
I have. I actually did it, believe it or not, on something you guys wouldn't think. It was actually Honda's.
Oh, I ran nitrous on my lawnmower,
Yeah.
but that's not nitro.
That's not nitromethane.
So, but
yeah.
I ran it on my lawnmower, a push mower, as a matter of fact. But man, would that sucker chew some freaking leaves up. But it did burn. It did burn a hole in the center of the piston.
Yeah. Well, I did quite a bit with the nitromethane on Hondas. Now, the guy's still running, so I'm not at liberty to say a lot of the stuff that we did. I was working for another car company. This is in Southern California, and I can't tell you his name or anything like that because he still runs it. And we did a lot of it. It really comes down to the camshaft. Now, he was running essentially methanol, and then you can switch over to nitromethane from there. And once I've said this before, but once you get over 40% of nitromethane, that's when you start to notice things. Things rapidly change from 40 to 50 to 60, and then once you get to that, I'm going to say 50 to 60. That's where the jump is just astronomical. It is completely different engine once you get over 60, and then once you start getting to that 90%, it just things happen.
Well,
fast.
what's weird about a nitro engine is like, okay, on camshaft, you would look at on a gasoline engine you would have a lot of overlap, right? But the more fuel that you can pack in the cylinder on a nitro engine, the better. So you have less overlap with long duration
on the exhaust.
Yeah.
You have a ton of duration. It's not even like a blower cam. Most blower cams are going to be like 10 or 15 degrees. You're going to have like 20, 25 degrees of extra duration on the exhaust, just because once you go to the nitro methane, it's because of the expansion rate, and it coming so fast. You can only run it for so long because the valves get so hot. Everything literally melts from just the heat of that thing.
Well, Val0360 Jimmy has a really good question down here at the bottom.
Yeah.
And I don't know if you remember, like the first time I ever met you, this is exactly what I was doing from the time slip, was determining how much lockup my converter, how much slippage my converter had.
Yeah.
And that's how you determine if it's sized correctly or if you have the correct converter. Okay, there's a few things that you need to know on this. If you're going to try to figure this out, one, you need the tire diameter. Okay, you need the mile an hour at the end of the track. You need the engine RPM at the end of the track. When you go across the stripe, you need to know that number. Okay, and ideally, whether you're running automatic or manual, it doesn't matter. But I mean, you're trying to figure out converters. So you're looking at an automatic, and remember, high gear is 1-to-1. It doesn't matter if it's Power Glide, if it's 904, it doesn't matter if it's a C4 or a C6. High gear is 1-to-1. If your RPM at the end, let's say, is 7,500 RPM, that means your drive shaft would have to be spinning 7,500 RPM. And if you sit down and do the math, based on your tire diameter, it's going to tell you how many mile an hour you were running, and you would compare that to what you have on the slip. Okay, now If there's any difference between that, that's all slippage.
It's a percentage of loss. That's right.
And how you do it is, you got to remember, it's got to be 1-to-1. So if your engine's turning 7,500, that means the drive shaft should be turning 7,500. If the drive shaft is turning slower than 7,500, you have slippage, and that's all mathematically. And you also need the rear end gear too. The rear end gear is the other one that you need. But you can do the math backwards to determine, the mile an hour, you need to know how many inches in diameter you're traveling per mile an hour, essentially. Okay, and then you do the math backwards. So let's say your tire's turning, I don't know, 2,500 RPM. Okay, if you have a 410 gear, you would multiply that 2,500 by a 410 gear. Okay, and that'll give you 8,000 something RPM for the drive shaft. All right. Remember, if your RPM going through the traps was 7,500, it probably will be lower. I mean, it's just poor math, the example I'm using, but that's what you're doing. That's how you do it. And you work it all backwards from how fast the tire diameter is going at that time.
Yeah. And a good number is that 7%, 5 to 7% is a very efficient converter. That's slippage. Once you get over the 10 number, 10 to 12 is crappy.
Did I tell you that I went up to Fontana and I couldn't run the whole quarter mile? And I sat down and did the math. I bounced it right off the rev limiter at 7,500, so I knew what the RPM was going across the stripe. But here's the sad part. I did the math backwards, just like I was telling this guy to do, and it had 27% slippage.
What?
Right? 27. And I'm like, wow, that is astronomically high. And I took it up to Art Car used to have that converter transmission shop there in like Long Beach area or somewhere around there. I can't remember. I had him tighten it up. Oh, dude, that was the biggest mistake I ever had.
Yeah.
Because I tightened it up, put it in the car, and it was like 24%, and the car fell off like 0.3. Right? It was horrible. And I really didn't gain much. And I ended up just having a converter made. I called the guys. At the time, the Street Outlaws was hot and heavy, right? They were fairly new, a couple of seasons in. And I called this torque converter company called Pro Torque up in New York. And the guy was like, no, man, we'll get you perfect, an 8-inch converter. I'm like, 8-inch, man? I had a freaking 9 before. You think the 8's going to do it? He's like, oh, yeah, trust me. And they sent me an 8-inch. And I put it in the car, and I didn't like it. And it wasn't until I took it to the dyno up in Fontana that you remember who's that guy? Where did they do the Engine Masters? Brule. Yeah. And I took my car up there and had it put on the dyno on the rear wheel dyno, right? And you could actually see the converter work in high gear on that thing, because what would happen is, you would get it into high gear, and the engine would just stay at like, I don't remember, like $6,000.
And it would stay there.
And the tire would go, whoa, and it would freaking explode in size.
Yeah.
Right? And you're like, wow, what the hell is that? And then it dawned on me, that's the converter locking up.
Magic. That's the magic of the converter. Yeah.
And then I took it to Fontana and ran it, and I want to say I gained like 18 mile an hour or something.
Yeah.
Right? From that torque converter, from going from 27% to like 6.
Yeah, it makes a big difference. And your 60 foot was probably the same. So
it was exactly the same.
Yeah. A Rangeline 6 with a chance of cannonballs. Would you say the biggest power loss between the 8 1/4 and the 7 1/4 is mostly a larger ring gear diameter with same ratio gear thickness, or is it pinion location too? Rotational, bigger axle, still turn close to center axis. Okay, so yes, you're going to get minimal on that, but it comes right down to the high point angle. That's where it comes in to the ring. The closer you come to center, less power loss. The farther you come down here, more power loss.
Yeah, but the weaker it is when it's closer to the center of the ring gear.
That's
the weaker
right.
The rear end is.
And that's why Ford 9-inch is so strong, is it's way down here. It takes a lot of power to turn, but it's also got that extra support gear on there, but it needs that extra support, the third gear, the bearing on there, so that way it doesn't want to walk itself up.
Right, because the farther you take it down at high point angle, the more stress it puts on that pinion too.
Yeah, that's why the 8 3/4. That's its good thing and its bad thing is it doesn't have the high point angle as a 9-inch, but it's still kind of down there. but it doesn't have that extra bearing on there, so that's the reason why they tend to walk, and then when they put too much load to them, they just come out to the side and they just strip all the gears right
That's
off.
why guys stay away from the weird center section 8 3/4, like the 741s and stuff like that, is because the pinion on them, I want to say, is a smaller diameter shaft.
741 is the smallest one. Now this is going to contest a lot of people, but everyone always says the 489 is like the strongest, but it's got a crush sleeve on it, right? I prefer the 742, and there's a reason for that. Is because when they built all these drag packs, the rear end that they came with on some of these was an 8 3/4 with an aluminum chunk. The only one that they ever made an aluminum chunk gear for was a 742, and it's because it's got a step on it, and so you can shim it, and there's no crush sleeve on it. So on the crush sleeve one, if you're going to run a lot of power to it, sometimes they will move, and then it will take some of that tension out of there, as far as how they're thinking. Now you can get one there where they shim it, so there's a spacer and you put shims in there to get your preload correct. But with the 742, you don't need to do that. It's already there. So that's the reason why I run that one, and it's just what I have. It's the most ones I've ever had, and plus everyone wanted the 489, so they were always out of the wrecking yard. So since I was pretty much Mr. Poor Guy, 742 is what I got, and that's the way it worked. In fact, my very first one was a 741, and it was a 391 gear, and that was the very first gear that I put in the car. And I chucked it out with the 250 shot of nitrous. I shot that sucker right out. But
mine was 7.5 inch Fords.
Really?
You used to be able, you could buy like 4 or 5 of them things to 8.8.
Yeah.
And it was like, well, damn, I guess if that's the case, I'll just keep replacing them, right?
Yeah.
So I throw them in there and freaking spit pieces out left and right, and then change the rear axle, go get another 7.5 inch Ford. It's actually the same axle, so you knew the axle wasn't going to break, but it was the ring gear. The ring gear would munch on them. There's a lot of questions coming in really fast.
No, I'm going to do this real quick. Michael Schmidt, Nitrous sounds erratic and unsafe for an engine. Alternatively, is it possible to bolt on nitro? Is it nitrous?
Yeah,
periodically
nitrous.
For drag racing? Absolutely. I would go definitely with nitrous.
That was my favorite thing to do. We used to call that the Dr. Jekyll, Mr. Hyde. You have a very drivable street combination, and then you whack that button, and man, she's a freaking murderer. Right?
Yeah.
It's just like I don't know. You get that girlfriend that's laid back but wiry, and then you feed her a whole bunch of crystal meth, and she's a freaking monster, right? So it's the same thing when you're talking nitrous oxide. And his next question was a 25 shot. That's not even worth it, dude.
No, go to straight to 100 to 150.
Yeah.
Just any V8's going to take 100 shot without even gapping the rings.
You're
can put
good on
100
cast pistons up to like a 125.
Yeah,
Okay.
and I ran cast pistons. I ran hypertentic pistons up to almost 200 shot if you do the timing right.
Yeah, you have to be conservative with the timing and the fuel on a hypertectic piston, because the first time you rattle it, she's done.
Yeah, and
right?
it shatters.
The
It shatters.
piston just will end up in the pan in pieces.
Lots of pieces. And also, too, you said right here, for periodic drag racing, possible to bolt on nitrous for mild safe improvement to power slip. Yeah, I started right at 100 shot, and then I went right to a 150 shot, and it was absolutely a great ride for 150 shot, and you didn't have to do anything to it. Once you get over that 150 shot, you got to start gapping things, rings, then you got to start worrying about plugs, timing.
Converter is a big
yes.
one, yeah.
Converter's
Because
a big one.
once you get over about a 125 shot, you cannot use a stock converter. It will literally spit pieces out of the input shaft. I had a Ford AOD, and I was using a 2500 stall converter, which was considered low, okay? But when I took the tranny out, it stopped shifting, so I pulled the tranny out. I could not get the converter off the input shaft because it twisted the input shaft so hard that it bound the converter to the input shaft, and I just ended up having to pretty much junk the transmission. So, because you can't get it apart without getting the converter off.
Yeah. And the one thing I did on those too is that I shredded the stator inside of one. I hit it so hard. It was already it was in second gear. It was on the street. So I launched it in first, and as soon as it started rolling, I pulled it to second because nitrous is torque. So I wanted to have all the torque. So I short shifted to second, hit the button, and as soon as I hit the button, it was already stalling. And I made it stall even harder, and it just basically just twisted that sprag inside the stator and literally shattered it. And it did the same thing. It ballooned it and then took out the bearing, the thrust bearing. So yeah, it was a dangerous day.
Michael Schmidt, if you look down at the bottom, he said this is a flathead 600 horsepower engine, a 25 shot. Okay, when you're looking at nitrous oxide, guys always throw the number out there, which is ridiculous. Okay, because it's really not the number that you're feeling. A 25 shot of nitrous oxide is probably, I would have to say, 60 to 70 foot-pounds of torque.
Yeah, because you're only going to increase the torque. If you ever watch, look at some dyno graphs of nitrous engines, and as soon as they hit it, the torque goes way up, and then it instantly falls off. It's like slowly falling off as it's going up. And then the horsepower is going to go up. But really what you're doing is you're building the torque. That's why nitrous cars at the track take off and they're gone.
They're brutal.
And then they're brutal. And then the turbo cars on the top end will come around them because that's the whole point. And the nitrous cars it's just all torque. So
yeah, and that was the thing was interesting about it because you'd whack that sucker. I would do it right off an idle, and I had that micro switch set up on the throttle blade. So as soon as I'm mad at that sucker, she's spraying, and I mean it was almost instantaneous. You had a lag, you could feel it because you're a human being, but man, the torque is almost addictive because it would come out of the hole. I was spraying with like a 200 shot, and I mean it's making 800 foot-pounds of torque on a 302 Ford. Well, the 302 Ford it can't make 400 foot-pounds of torque, and if it did, it'd be around 2,500 to 3,000 RPM.
Yeah,
and when you're getting it right out of the hole, right off of idle, it's a completely different story.
Yeah,
you'll like it.
I couldn't do it out of the hole because I would just lose traction. It would just, these are street races with no prep. There's not like anyone out there, hey, we didn't prep. If you soaked your tire in VHT, that was a prep, So I would roll it out of the hole in first, and I would short shift to second, and then come into it, and that seemed to work the best because that way I could carry second gear really far out there.
Yeah.
And I wouldn't run like a 411 gear. I was running the 391. Then I went to a 355 gear, and that really, it kills the torque, but it allowed me to carry the torque longer because I could stay in the gear longer.
Well, that's the ideal gear ratio is the 355, 373, right?
Yep, exactly.
For
street racing nitrous
for
car.
for a nitrous car. Now, Michael Schmidt, if I was you, I wouldn't even bother with a 25 horsepower shot. You're not going to notice it. It won't do much for you. Put that sucker up at about 75 shot, and you'll be happy with what you got. Don't get greedy. It's on a flathead 6, but I'm telling you, because it's a flathead, the torque is going to be amazing. You're going to think, dude, I got 2 engines under there, right? So I mean,
he goes, I don't know shit about nitrous, but fun try. It is. The first time you hit the button, it is a kick in the pants.
Addictive, man. It is addictive. You want to run that sucker just doing nitrous burnouts through the McDonald's drive-thru. It will be addictive, and you'll love it, and you don't have enough bottle for it because you'll be filling that bottle. It used to be nitrous was like $2 a pound, right?
What's it now?
I don't know where it's at. It's probably somewhere close to $8 a pound, I'm assuming. But it used to be almost nothing.
Yeah, I remember that.
That was the thing is like, you go to a nitrous car was so awesome because you could have a regular car you drove to the track.
Yeah.
Air conditioner on, cruise control, the whole 9 yards. Pull in there. You turn your nitrous bottle on. You take a gas can with 5 gallons of 93. You dump it in there. And you set your timing back, okay? Because it's like 4 degrees for every 100 shot, I think is what it is total. So you want to pull 4 degrees total out of it. And it would be amazing because there would be stuff that was not fast by any means, a stretch of the imagination, and nitrous oxide would make them stupid.
Yeah, it was literally like a race car now because you doubled the power. Some of those guys were a 250 shot on a car that, remember, we're talking back in the 90s when cars were making, you made 450 horsepower, you had something. Most cars on the street were running, if you had a 13-second street car, you were ruling. You ruled a lot of people. I was in the 13s, and there was not many times I was beat. And when I put the nitrous on it, I was literally in the low 11s, high 10s in that car, and there was not too many people that would beat me. That you had to have a really, really fast car.
I had an 1170 street car. That was in 2001. 1170 on nitrous. Okay.
Yeah.
On the motor, it would run 1290, somewhere around there. 1170, piece of cake, no problem. Drive there, cruise control, air conditioning, the whole 9 yards. 8th mile, though, is where it made it up because that was where all the torque was at. So you show up at the 8th mile track, and it would go from 770 to run like a 620. Right?
Big
Guys would be like, wow, that thing is stupid fast.
Yeah.
And it was just because it's all torque. It's all torque. You know, the horsepower is actually just a mathematical figure of how much torque you're making. Right? Yeah. And it gives you, I don't know, misleading numbers when you look at the number on it because they're looking at horsepower numbers. But in reality, let's say you're doing 400 shot of nitrous, you're getting 400 horse, but you're probably getting 800 to maybe 900 foot-pounds of torque out of that stuff.
Yeah, if you watch some of those things, you watch some of those graphs, you'll see them. They just literally are like sloped the wrong direction for torque. It's instant peak, and then it just slowly
falls right off. Yeah,
it falls right off. Patrick is saying something. Shane, I agree with you. A 489 is a tapered pinion and tapers down to the same size as 742, which has a straight pinion. Yeah, I agree. That's why I've always been a 742 guy. Once I started building my own, I was like, why do I want the 489? When I actually bought a 489, I was actually able to afford one. I took it apart, and I'm like, why do I even want to mess with all this? The 742 was so much easier, so I just stayed with that one. So that's why.
And then the crush sleeve stuff, a lot of guys shy away from the crush sleeve stuff. The 12 bolt, the 8.8 Ford, your Chrysler 8 3/4 stuff. Don't sweat that crush sleeve. Okay, the rule of thumb is you want to take it out because what will happen is under heavy load it'll crush that crush sleeve further, and then the pinion will be out of alignment and you'll break the pinion. But they make things called solid spacers.
Yeah, that's what I was doing.
Yeah. So you would take that crush sleeve out. You would actually technically you would put it all together with a crush sleeve, and then you would measure how far that crush sleeve is crushed, and then you would put a solid spacer in there that can't be crushed any further, that same dimension.
And it works just fine. It works just fine. But that's a lot of work when you could do the exact same thing with one setup on a 742. That's why I just stayed with it. Because I did buy a 489, and I got the spacer with all the different spacers on it. So I just built it with a crush sleeve, and before I even put the thing in there and just spun it around. So I got my 10 pounds of resistance. Took it back apart, measured it, set it up, and I'm just like, well, this sucks. I just like the 742. That way I did it once, and I didn't have to mess with it. Clayton's asking me, I hear the Ford eats up horsepower. How much horsepower do you lose using a 9-inch with other differentials? I don't have a clue. I do know it's noticeable, though.
There is a lot of tech. If you just Google that same thing on,
yes,
you're going to find a lot of information on the web. But in reality, the 9-inch Ford is the king of all power eaters, right? Mm-hmm. It is the highest power eating rear end that there is. It is strong and plentiful. That's why people use them.
Yep. And it's a chunk, so you can change gears easily.
When I was doing research on rear ends, the 8 3/4 Chrysler was the one I wanted to use because it was the least amount of power of parasitic loss, right? Now, that's for front loaders, and that's kind of misleading in itself because that's if you're looking at all the rear ends, they're not going to check, a 1956 Pontiac rear end. They're not going to check it, right? Yeah. Because there isn't nobody running that. There's very few of them out there. But what I did find is the 9.3 Pontiac Olds from like 57 to 64 is probably one of the least parasitic loss rear ends that there is, and it's stronger than a 9-inch Ford. It's actually stronger than Dana's 60. Yeah,
we were talking about this a few weeks ago. I want you to get one and run it.
I have it.
That would be awesome.
I have.
Oh, you did? You got one?
Yeah,
oh.
I'm going to run it in that 63 Buick.
Oh, that's awesome.
Yeah, that's awesome. The thing is so humongous it looks like a dump truck rear end from the back.
Yeah. Okay. You can you read this one for me because I
No, I was going to look at Tom Brown's where he says there aren't any rear axles with straight cut gears. Yes, the old Ford Banjo rear ends used to be straight cut gears, but you're going to have so much gear noise you won't want to ride in a car.
yeah, right, they're loud.
Yeah,
Yeah.
that's the downside of straight cut gears. They're stronger than hell, but man, do they whine. Right, that's
Yeah.
where your rock crusher Muncies come in. Is they had straight cut gears. If you go to a lot of the Ford or not Ford, 3/4 ton pickup and up transmissions will have generally a straight cut first gear, even if it's a granny low, and they whine like mad.
Yeah, my Power Glide that's going in the Cookie Monster, it's got straight cut gears for a 1.8 ratio on it.
Uh-huh.
So yeah, we put it on the dyno, and it's definitely noticeable. It's got some noise in it. Patrick's saying, yeah, I've been there that last year with the crush sleeve ruined my 1923 gears. Yeah, I did the same thing, and I didn't. You always learn the hard way, and that was the hard way. Yeah, I've done. Yeah, that's expensive. Okay, Tom Brown's. Where's the Banjo quick change rear end straight cut? Right? Remember those? Do you remember those things?
That's what I'm thinking. Is the Ford Banjo rear ends? I think were straight cut, and I think that's the only one I know of.
Yeah. Now there was a company that was doing this for a while, to where you could. It was like what are those sprint car rear ends?
A Winners quick change.
Yeah, you could just quick change them back. You know,
They're straight cut too, but they don't have they don't have a ring and pinion like you think, right?
Yeah, it's different. Yeah, it runs reversed because it goes this way and then back. You know. Yeah. So, all right, let's see what if you could best both worlds, 7 1/4 pinion style location billet magnesium pumpkin with 742 casting style pinion with Dana Ford 9-inch front support that fits 8 1/4 housing. Build it.
Yeah, you'll probably be poor.
Yeah, that would be very expensive.
It's a lot of one-off stuff right there.
But I'll tell you right now, the 7 1/4 style pinion location, that would be the killer right there, because you would lose everything else, because there's less contact with the amount of gear surface, because with it being where it's at and the helix of it, that's the whole beauty of a Ford 9-inch, is because you have so much gear contact. When it gets closer to the center, you have less and less gear contact, so you wouldn't be able to make the gears big enough and strong enough to support that. And that's the reason why the high point angle makes the big difference, is because you have it's how much helix is also in it and how much is it touching on the gear.
It's called tooth engagement.
Yeah,
right.
Yeah,
That's
exactly.
the big one. Is it your tooth engagement on a low helix rear end, because it's got so much cut to the pinion.
Yeah,
Right.
helix.
There's
yeah.
the engagement area is like, because you got to think of it, you're taking a circle on an angle. So you put it at the very bottom of the circle, you got a ton of engagement. You put it at the center, and you have the least diameter of engagement, the least surface area of tooth engagement.
Yeah, exactly. 8 1/4 and 4/9 don't use C clips. Yes,
Correct.
That's
Yeah.
right.
They're bolt-in axles. There's actually some of the GM 8.5 inches that were like that.
Yeah, that's my favorite. In fact, the 7 1/4 that I have on right now is a later model 7 1/4, and it's got the 8 3/4 green bearings on the end of it, and it uses the 8 3/4 brakes on it. So I think it's like a 70. I think it's a 78 or 77. So it's got the the bearings instead of the flat bearings that ride on the axle. This, when the bearings go out, I can actually change the bearings out. So that was the reason why I picked up this axle.
Well, that 9.3 Pontiac is a bolt-in axles, and it uses the same size bearing as the large diameter Ford. Right? It's that thing is, I'm telling you, is hefty. It is one hefty piece.
If you're in questions about a GM 8 125 dropout diff or a 5564 Chevy, can anything be done to beef them up? How much torque do you think they can hold? I know nothing about them.
Oh, dude. I don't know much about them, because I'll tell you right now, most guys that were racing those took them out and put the 93 Pontiacs in them, because they are that. Okay, think of it. The ring gear is actually smaller diameter than the 8.2 Chevrolet, which was a turd bucket. Right? I mean, that thing was a pile of crap. That 55 to 64 Chevy rear end, if anybody was running a stick shift car, they would have had a 93 Pontiac olds in that. I don't know if anything can be done to beef them up, but I'm going to tell you right now, get out there and find yourself a 9.3 Pontiac. You'll be so much happier. It'll probably come with a 267 rear end gear and an open rear end, but there's parts available to put whatever gear ratio up to, I think, 512 in it. You can get spools and the whole 9 yards. But I'm sure you don't need that, but that rear end, that 9.3 Pontiac, is going to be everything that you could throw at it.
Yeah. Okay, Patrick's saying that, but the 9-inch has a rather large seal straight roller bearings, where the Mopars have the tapered roller bearings.
Yeah.
Yeah, but that's, yeah. But I always change mine out to the green bearings and just press them on. And I love those green bearings, because then that way you keep the leaks too. You don't have to worry about that inner seal so much, because the bearings are pretty much the seal. Well, anyways, we don't have much tech questions coming in, but we were going to talk about something at 8 o'clock, and that kind of already came by and went, but...
yeah, ported versus unported vacuum, right?
Yes, ported versus unported vacuum. So here's what we did, is that a little while back, a few weeks ago, actually probably about a month ago, we asked our viewers to send us a video, and we will myth bust it, or we will talk about it in our own, what we think works. So this person wants to remain anonymous, so he doesn't want to be named. But it was, right now there's a big thing about ported versus ported, ported versus unported versus manifold pressure to your
Vacuum
distributor.
Advance.
What would you run, and how would you run it? So I'm going to let Dallas start, and then I'll tell him mine. Or do you want me to go first, or do you want to go?
It doesn't matter.
Okay.
First off, I'm just going to establish Vacuum Advance is primarily used on a street car. Okay, you don't use this on a race car at all. Generally, you put the timing at, let's say you're shooting for 36 degrees total. You'll set it at 36 degrees on a race car and just leave it. Okay, yeah. There is no Vacuum Advance. There's nothing like that. It's just literally set it and forget it. Now, on the street car, the whole purpose of vacuum to the Vacuum Advance is that when you're cruising down the highway in a high vacuum situation under light load, right? Because you're up at operating speed, there's a light load on the throttle. And what happens is your Vacuum Advance will come all the way in, and it'll pull as much vacuum, pull as much timing in as you have adjusted for that Vacuum Advance. Or if it's a set Vacuum Advance, it'll pull in whatever the number is it's rated for. Okay, how many degrees of timing it's going to pull. That's primarily just used for fuel economy only at cruising speed. All right. Now, when you hook it up to, let's say, the two different scenarios is ported and unported vacuum. The difference between ported vacuum and unported vacuum is below the throttle blade. Okay.
So it's manifold.
Right. It's directly below the carburetor. It's just like you're taking it from the intake manifold. Ported vacuum is above the throttle blade. Okay, so it's however much throttle you have open is how much vacuum is available. And if you think about it, it works kind of a little bit different than what you're thinking, because let's say you got the throttle blade open really far. Well, the vacuum is going to be low at that point because you got the throttle blade all the way open. There's not much vacuum there. When the throttle blade is almost closed, there is no vacuum there. So what you're looking at is, at an idle situation, your throttle blades are generally closed, and it's just going by, like your, damn it, what I'm looking for here. It's just running off your idle circuit.
Yeah, slot. Basically, there's a slot right there. Yeah.
Right, your transfer slot. There's little to no vacuum on that ported vacuum at all. You don't need fuel economy at idle. It's not under load, so it's already under a huge fuel economy issue, right? It's already working at just whatever's going through the idle circuit. When you take that from an unported slot and put it on a ported vacuum, now it's giving you all your advance, and you'll have to generally dial your timing back from your total what you had previously set, because it's going to be too much timing. And what I found is, generally when you run a Vacuum Advance to ported vacuum, your engine idles smoother, it gets better fuel economy. You're not using your Vacuum Advance as a crutch to make the thing run okay. When you put it on ported vacuum, or yeah, oh, I'm sorry, I have that backwards. When you have it put on ported vacuum, it gets a better idle quality. You have it runs cooler. Okay, when you put it on unported vacuum, what happens is all your advance is coming in right off of idle. Okay, like literally on idle, you have ported vacuum. I'm sorry, unported vacuum, and your advance will be all the way in. So you'll have to dial your timing back, and what will happen is your engine will run hot most of the time because it's got a lot of timing in it. It'll start easier, just because the timing is going to be so retarded because you have no vacuum under starting condition, right? So your vacuum advance is backed all the way off, and your timing will probably be pretty damn far back. Now they generally start easier, but as soon as they start up, it'll go right up to it'll pull that vacuum, or pull that vacuum canister, and it'll be all the timing will be in right there at idle. So I've found that if you look at the factory manuals, they all go to ported vacuum. I've never seen a factory manual where it has it going to unported vacuum to the vacuum advance canister. I can't see any situation where it would be a gain, because with constant vacuum pressure on that diaphragm, eventually it's going to fail. And when it does fail, you can't even hardly drive the sucker.
Yeah.
Now, if you look at where it's going to ported vacuum in that same situation, the only thing that happens is the car run the same exactly as it did before. You're going to lose your fuel economy. That's it. So that's my take on it. I don't know if I've rambled on long enough.
No, you did good. So I'm going to take a slightly different approach. Is that I want to qualify a couple things. One, I was running this past Dallas earlier, but when you Google, does a lean mixture burn faster or does a rich mixture burn faster? Well, you Google it up, you're going to get two different answers. And the reason being is you're not putting any quantitative numbers on it. So let's put some quantitative numbers on it, and let's give a range.
I'll be right back.
All right. So once we do a range, we'll know exactly what we're getting. So the range that we're going to deal with is that you don't really want to run an engine as far as what we're doing. Okay. Now fuel injection is totally different, but a carbureted deal, 16-1 and higher, that would be considered lean. Let's call it 10-1 and lower, we're going to call that rich. So basically our range is going to be from 10 to 16 to 1. That's going to be our range. 16 is going to be our what we qualify as lean. 10 is what we're going to qualify as rich. Now in those scenarios, between those two ranges, this is why we're qualifying this, is that 16 is going to need more timing to burn because it's going to burn slower. The 10-1, or let's call it, just before 10-1, is going to burn faster. So now that we've qualified that, I have tried it many different ways. Most people who have a performance engine, you're going to have a lower than stock vacuum when it's idling. So therefore you'd want to be ported vacuum. So that way you're running off, say, like 10 or 15 degrees of initial, and then as you're cruising down the road, say you drive it on the street and you're going down the road, it pulls a little timing and you get a little better mileage, because you're not going to have a high manifold pressure. Now, I've also tried it. Now, the engineer in me knows that at idle, you have a very, very lean mixture. You need a lot of help with timing to get it to burn efficiently. So that's why before all this emission stuff came in, you could essentially on a car that's trying to get mileage. And the reason why I know this is because I tried this with the Slant 6. So I hooked it up to manifold pressure, to manifold actual vacuum.
Unported, right?
Yeah, actual no, not ported. I actually hooked it up to that.
Unported.
Unported. Yeah, so manifold to manifold vacuum, full manifold. So and then I to get the idle down is that I had to dial it way back. Now this is with the stock camshaft. I think it was it was a bump above. I think it was 208, 212, and I had it on a 112 LSA. There was almost zero overlap on that, so there was no boogity. It was the whole idea that was mileage. So I had to pull the timing way out of it, and I had the Holley 2 barrel on it this time. I had to back that thing way off, and I was able to lean that thing way out because I had so much. It had 10 degrees of initial, plus I think it had 15, so I had 25 degrees of timing at idle. Now, people are like, oh, that's crazy, but it's so lean that it needs that, because that's actually what you need at idle, believe it or not, when it's that lean. Because it's the worst time. Everything's happening slow. There's a very crappy fill volume. You have very shitty distribution between the fuel, so you need all that lead in it to get that flame front to get across there to burn, and it's burning so slowly across there. You need that lead. So I tried it, and from an engineering standpoint, that's what you should have for mileage. Now, it did not work for me. I think the slant, because it's got a 3.4 bore with a 4.125 stroke and a 225, it just wouldn't work. I think because the bore was so small.
Well, it detonates so easy with the small bore engine.
And a long stroke, exactly. And that's what was happening, is it was detonating so easy. So I noticed that my initial, I would have to back it down. Then I went to ported, and then I was able to run 11 degrees of lead at that time. And then I put the weight so that way it would come up to about 22 degrees, literally off of idle. It would stay at 22 for a very long time, and then it would slowly go up to about 29 to 30 degrees, and then it would lock out at 30, and then the vacuum would come in, and then it would bring it up. I think for my situation, this is the only time I ever tried this, was on the Slant 6. I think because it didn't work is because of the small bore, long stroke, big long rod. But if I had a bigger bore, a somewhat shorter stroke with a reasonably length rod, like say a 350 Chevy or a 360 Chrysler, 318 Chrysler, 340, whatever, or 302 Ford, I think that it would be worth trying a full manifold vacuum at idle on a non-performance type of vehicle for mileage, because that's actually what it needs, because it's lean. The reason why we don't tend to do it is because we're going to be doing a lot of performance things, and that's with like 20 inches of vacuum and let's call it higher. Once you get under that, like say 18 inches, and you're like really, I wouldn't even call it 18, more like say 14 inches of vacuum, and you start having some overlap in there, it's going to start jumping all over the place. You need a nice dead steady vacuum, because what's going to happen is when you have that vacuum advance hooked into manifold, unported, and it's hooked in, and it's going to pull that advance. If you have any type of fluctuation, it's going to start going around, and then it's going to start surging that engine all over the place, and it's not a very good idle. Also too, I noticed too that when I did this and I put it into drive, it would put a load on the engine, which then brought down the amount of manifold vacuum, and then it in turn brought down the amount of advance, because you've got, instead of 15 degrees,
it almost died. So it was a really crappy way to set it up. Now, it would, if you had a bigger engine that had a sloppier converter, it might work fine. But then once again, now you're negating the point of having vacuum, the whole vacuum advance thing, trying to get mileage out of it. So it was kind of one of those things that was, it was robbing Paul to pay Peter. So I went back to the ported personally for me, and I liked having the initial on it. But most of the vacuum advances have an Allen wrench that you can go in there and you can adjust how fast it comes in. So I set mine up on the Slant 6s to come in really fast with the amount of the adjustable vacuum advance.
Yeah, it's adjustable, and they come right from the factory like that. Well, not factory, but I bought a vacuum advance from O'Reilly's that I put onto the factory one, and it worked beautiful. And I could dial it in when I wanted it to come in. I just blew out a little vacuum gauge, and I would pump it up, and I'd watch it move, and then I dial it in, and it worked. It worked amazing. I just let the car run. I just had a timing light on, and I just, okay, well, there it is. And I would drive down the car, and I had a vacuum gauge right on the dash, and I would see as I would go up and down hills where I was at, and I would know, okay, I needed to back off here, I needed to come here. So for me personally, on the Slant 6, I didn't have any luck with it, only for two reasons. One, it was detonating under light load sometimes, because it was very prone to detonation because it's a small bore, long stroke. And also your tuning window is much smaller when you're running the vacuum advance to manifold, unported. Your window's very small. So heat is a factor. Idling, when you're coming off the freeway, it was a problem. Also, when I put it into drive, it would pull the engine down, pulled the amount of vacuum down, which pulled the timing back. So it was just a bam, 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 bam type of deal, and it would almost die. So if it was at 800, it would like almost be chugging at like 400 RPM. when I did that. When I went to a ported, it could be at 800. I'd put it in gear and it'd be at 750 because it wouldn't change the timing much, because the timing was 11 degrees. It would still be 11 degrees.
I made a degree wheel for my distributor, for HEI diameter distributor, and I would zero it, and then you could actually just take the line off. You don't even need a pump. Just suck on the thing and see how far it goes, right? And then you can, with your degree wheel, you set it to 0 where it's static, and then you suck on the air tube, and then it moves over, and you can read how many degrees you're adding in. Now, what pressure, I don't know. What vacuum, I have no clue, right?
Yeah.
But generally what you find is those things are, the way I set them is, I just set them to a stock setting, which is like generally 7 to 8 degrees it adds in. And then you play with it. You add a degree or two, and if it starts pinging, you back it down,
Yeah.
and then that's how I normally play with it. But I try to get it to where it's right on the edge of pinging.
And then
that's
back it
where,
down.
Yeah, back it down like a quarter of a turn or a half a turn.
Yeah, I go
So-
2 degrees from that. So on mine, it was 15 degrees is what the engine likes. So 45 degrees of total timing at, say, 2,000 RPM. That's where it was full vacuum advance. So it was about 45 degrees, and it just loved that. Anything more than that, if I ran 1 degree more of initial with centripetal force, so like 31 degrees, it would ping. So 29 degrees is the number. If I ran 47 degrees, it would ping. 45 is the number. So, yeah.
Well, there's a lot to that. Now, there is a question that's come up. First Responder Garage says he disagrees with us.
Okay.
But I did find that there's a major difference in power when you start going over the recommended, and it's all the recommended timing, and it's
Yeah.
all
Oh, yeah.
based on the
Silver
chamber. What's based on the chamber shape and
Oh, yeah.
size, right?
Yeah.
So, like I had my Cleaver Ford, we had it on the dyno there in was it Gardenia or freaking whatever it was, where Brule works at, right? And the guy that made the heads told me, he said 29 is the number, dude. And I'm like, yeah, that's awfully low. Jeez, let me try up to 31. And it fell off 40 horse on the dyno, and you just put it back at 29, bang, there you go, back 40 horsepower back.
Yeah, because it's the pressure, because you're pushing against, because the flame front's going across as the piston's still coming up, so you're losing work, because now it's building work against the flame front, and then it goes down, and then the explosion is not pushing down anymore. It's actually already across and it's going down. So yeah, you'll lose it in 2 directions. So he's saying that I disagree. You guys are assuming equal fill wall to wall air fuel mixture, whatever the mix. What that doesn't happen, and the bigger bore even worse. Okay, I disagree. You guys are assuming equal fill wall to wall air fuel, whatever the mix. What that doesn't happen. The bigger bore.
He's saying that you're assuming that the fill in the bore is exactly the same, whatever the air fuel mixture, and
well, it's in flux. It's always changing. That's the whole problem. Is that you're trying to get cylinder fill out of it, and when does it with a bigger bore. With a bigger bore, though, you're going to have a little bit more of a cushion as far as your timing window, your tuning window. I'm not reading the question correctly. Or?
I can't quite follow the question.
Yeah, I can't follow it. Try to
I'm
get
assuming
first
that
responder.
I'm assuming he's talking about the fill rate on each cylinder is going to be different,
Of course.
and that with varying differences in air fuel ratio, it'll never be exactly correct, right? That's what I'm getting at. Like I always have on my Suburban, I always have the one cylinder that pings before the rest of them. I don't know why. I think it's back on the driver's side, all the way in the back, and I think it's because of the heat that it retains in the cylinder compared to the ones in the front next to the fan or the water pump. But that's just me, and I always have that one that's pretty much detonating all the time. So
Yeah. So I've tried it both ways. So I'm not gonna. I guess I'll call it. There was one. I think it's called the Junkyard Necromancy and First Car Garage. I think were the two people. They're friends, right? But the Junkyard Necromancy or whatever guy, he called out a Tony and Thunderhead 289 for where they're putting the porting at. The thing is, though, is that it's not a right or wrong answer. It's what are you doing? You can tune them for both. And if you're running for mileage, then you could start to tune for unported, but your tuning window is going to be much smaller. With the ported, you're going to have a much bigger tuning window, and you're going to allow for things of heat and heat soak and fuel vaporization, and you'll have a lot less problems. That's just at least what I've ran into. But you can make either one of them work. So I hope that was as diplomatic as possible for that. So I hope you guys got something out of that. Tom Brown's asking, whatever happened to the days of being able to change the timing on the fly from the steering wheel? I did that.
You can still do that.
I had an MSD dial. Yeah, because, in San Diego, when I had that big truck, it had those 35-inch tires. We had to go up these grades that were 6% for, miles. And that thing would get hot and hot and hot. And it would just be detonating going up the hill. So we would be able to back the timing off, just get over the hill, and then be able to turn it back up.
I hated towing up those, where it was like a 10-mile, 6% grade coming out of El Cajon.
Yes.
Going up whatever that mountain is there, that mountain range.
Yeah, mountain. Yeah.
And it was like,
mountains, yeah.
It would, like, holy crap, you could just watch the temp gauge climb. If you were on it just a little bit too hard and you were saying you were trying to run 70 miles an hour, man, that shit would start getting hot. And I don't know what the training was doing. It had to be even worse.
Yeah, the worst is coming the other direction, because you're below sea level in El Centro. Sea level's up about like 50 feet or something like that. I think Highway 8's 50 feet below sea level. And then you climb, and you start climbing before you even realize it. You're still in the desert, but you're climbing up that little slope. And then when you get into the mountains, it goes up to like 6%. And then you go all the way up to 4,000 foot. And you go to 4,000 feet 3 times before you start to descend. The Ducati Divide is the last one before you start going into it down. So it's a long ways. One thing I didn't mention too, that on the manifold ported versus non-ported debate, is that I've always had a problem with heating. I know you just touched on this, but when I did the timing, when I did the unported to my vacuum advance, and it was idling, there was so much heat being generated in the engine that it didn't have much heat rejection. So when I got off the freeway and I pulled up to the light, now a Slant 6 is a big long engine. The water goes this direction, it comes all the way back this direction. It would get hot, and when I had the distributor hooked up that way to full manifold vacuum, it would heat up even faster. So it was a big thing. Yeah. San Jacinto, that was it. Yeah, I call it Mount Laguna because that's the actual peak. But yeah, it was the San Jacinto Mountains. Dizzy Izzy's correct on that one. All right, another scenario: rainy Slant 6 with a chance of cannonballs. Shane, on Slant 6 with Edelbrock EFI carb body, you aren't running stock 1 or 2 barrel air cleaner, but if you took stock 72 stovepipe hose, vac operated snorkel cleaner, mounted temp sensor to get it warm sooner. I've done that. The wife had a 71, and I didn't do it with the EFI obviously, but we did a snorkel on it. But the way I've have the car set up right now, as far as the bypass, on the bypass hose, I don't have an open bypass. Now the bypass hose is there, but how I have it done is I pressed a brass plug in there, and I drilled a very small hole in it. So there is a bypass in it, but my engine, I can start it up and I can drive down the street. I get to the very first light and the thing's already at 145 degrees. So it heats up rather fast. Also too, I have less than 160 thousandths hole in the thermostat. So there's very little water bypassing. I tried a 125, but because I have a big aluminum radiator on it, it actually would take even longer for it to heat up and I'd have more problems. But the way it's set up right now, it heats up rather fast. So
I take all that shit off. That's more things to fail.
What's that?
All that stuff.
Oh, what he said, yeah.
The choke stove, the diaphragm. I take all that crap off because it's more crap to fail. And I get in there and start it up, and I just start driving. Yeah. And I tune it just for that, and usually by the time I get to town, it's usually about 3 miles. It'll be at 180 already.
Yeah, exactly. So I'm not worried about that. Okay, maybe this is answering his question, asking his question better. First responder garage. The cylinder will have rich and lean spots. It will not be an equal mix. When the bore gets bigger, you will have more area for rich and lean conditions and create knot conditions. Yeah, but we're not dealing with a 4.5 bore here. We're dealing with something from a 3.6 to a 4 inch. That would be something once you get over 4.5. Yeah, you will see that because that's a very large bore. But when you're going from like a 3.4 to a 4-inch bore, you're not going to see much. It's going to be really homogeneous, so you're not going to see this much. Okay, I'm leaving the table here. Okay. Someone said that you're not hitting the head, you're leaving horsepower on the table. Not true or close. And you're at the cetane trapping lens lean areas. I tried it. It melted the tight quench and rich and open area of the piston.
No, that's a true statement.
Okay.
You're wrong on that one. That if the tighter you get, if you go listen to a drag race only engine, like let's say, generally you find it in like top dragster situations where they got like a rear Morrison engine. Mm-hmm. You'll hear them squeak when they're running and idle, and that's because they're so tight that the quench on the cylinder head is causing them to squeak, and they're within probably 1,000th. You're leaving power on the table if you're not getting it butt up against it. It should, if you have it right and your machinist knows what he's doing and your engine builder knows what they're doing, it will literally leave a mark in the carbon.
Yes, the valve will. In fact, you know who told me that one was Joe Sherman. Joe Sherman.
He told me that same thing.
Yeah, he says if you don't see the valve impression in the top of the piston after running, you're leaving power on the table. He goes, if you don't see on the piston the actual outline of the cylinder head, you're leaving power on the table. That's exactly what he would say. Yeah. So and his engines had a unique sound to them also, from that. So
they squeak.
Yeah,
because it's so tight. Something with a quench style cylinder head is going to squeak.
Yeah. All right. Renaissance 6 with Chan and Cannonballs. You could take those components and adapt with a cold air box duct, a snorkel, flapper, door. Everything you're saying right here would probably work, but it's much more crap to fail. The whole idea of this is to have it as easy as possible with less failure. I understand what you're trying to say and everything, but
they run smoother when they heat up faster, and that's what the whole idea from the factory was. But all the stuff that it takes to operate it, one, you can't get it anymore, right? And two, they fail.
Yeah, all the time. Lisa's old, my wife's old 71 or 70 Dart that she had, a slant 6 in it. It had all this stuff because it still had to be smogged. This is in California at the time. They had to be smogged. So it had to have the flapper valve, the heat riser, the air cleaner, and all the little valving on it. And it always failed. There was always something going wrong with it because they just never worked correctly because it's old. It was at 40-something years old then, and it's like 50-something plus years old now. The way my Dolce Duals come out and the way that the exhaust pipe is, they're not wrapped. I fire that thing up, that intake manifold is hot literally in a minute or a minute and a half. There's so much heat being generated right next to the intake manifold. It's hot fast. One day I'll do a video of that. I'll start it up. It'll be 32 degrees outside, and I'll do it, and I'll start it up, and you'll see how fast that intake heats up. And it heats up so fast that I'm actually looking for a way to kind of get some of the heat out of the carburetor from boiling the fuel when it's sitting there. So, yeah. Okay. Dan was saying just the carbon. Yes. Just the carbon.
Imprints in the carbon.
Yes.
That's how tight you're getting them.
Yeah. 80, when he would say 90,000, he goes, 90 thousandths. He goes, that's 90 thousandths of compression you're losing right there. He goes, get that thing down to 5 or 6. And I'm like,
I remember the first Buick V8 that I did where I took it to zero deck. And then I had the head was virtually like, I want to say I used 20 thousandths head gasket, the steel ones for a 300. That thing was so nasty compared to regular setup.
Yeah.
Yeah, I mean, like, you're like, what in the world is going on here? Hold on a minute.
Yeah. Yeah. So what he's talking about, I did the same thing. I'm actually doing right now on the Cookie Monster. I actually have the piston coming out of the hole almost 10 thousandths, and I'm running a 30 thousandths gasket. And with the piston rock, I've got like 15 thousandths of piston rock. So it's a really, it's going to be tight, but it's a race car, so who cares? All right, let's see here. Rain and Slant 6. Let's see what other contraption. I hear what you're saying as far as simplicity, and your Slant 6 warms up now in summer, but how about wintertime? No, it heats up just as fine in winter. In fact, before I even hit the end of the street, which is less than a quarter mile away, I fire that thing up, I back out, and I go down the street. The heater's already coming on. Because once again, I hooked up the bypass where it comes out of the head. That's not a full open hole. I put a brass plug in there that's pressed in, and I drilled a small hole in there. I think it's 125 thousandths. So it's got a very small hole that bypasses, so it heats up rather quick. So there's not hot water going right back down and being cycled back through. So all the heat stays up into the head, and then I have a small hole on the thermostat. So it not only does it help heat up faster, like as far as the cylinder head, it also helps with, once it's already hot, keeping it cooler faster. So it heats up. It heats up well. Now, a lot of people were saying that defeats the heating of it because you're putting not heat back into the engine. Correct, but I'm putting heat. I'm heat soaking the head faster, and that's what I want. You want to have the head as hot as possible, so that way you can get the most efficiency out of it. And that's actually what I was trying to do is make the heat up as fast as I could. Man, it's already 8:51.
Yeah.
Wow. All right. Tom Brown was saying, Dan E. Boyd, one of my favorite builds of the car was a pre-war Amelia Air with a 12-liter Aero engine. It had 2-speed cog to chain drive at the Gouda Road and racing YouTube channel. Very cool. Yes, I've seen this thing. Have you seen that, Dallas? That one?
Probably. I don't.
You gotta Google that one.
I'll Google it later.
Yeah, it's a good one, man. It's ridiculous. It's like the thing runs in a very small power window, and it's farting and popping, but it's making so much torque. He's coming out of the corners.
That's like the Buick Bug. It's like 800 something cubic inches, and it pops, farts the whole 9 yards, and it only runs good from like 2,500 to say 4,500. But that's back in the infancy of automotive industry, and that's where it was the greatest.
Yeah. All right. So here he's saying, first responder garage. I get someone told you, but I've done it. The top of the piston melted on the non-quench area was black. 4-inch bore, small block Chevy, hump heads, and a piston had
craters.
Are we? This is all about the.
This
quench
is all
deal?
about the quench. Yeah, how much you're leaving on the. I'm telling you right now, someone did not tell me that. That is standard engine building 101. So I don't know what you did. I have no clue. I can't say. It doesn't sound like your build worked out well, but I don't know what you had. I don't know what you're doing. I know that's standard engine building 101. Dave Rear talks about it extensively in when he gets interviewed for magazines. Is quench.
Quench
right?
is a big deal, man.
And I mean, I've heard it from many other engine builders as well. But telling you right now, if you go look at a drag race only engine, you'll hear them squeak at an idle, and that's because they're so tight that the quench themselves is probably within a thousandth or two.
Yeah. I'm being safe, and I'm at about 15 with piston rock. So I have 30 thousandths, but I have 15 thousandths of piston rock, so I have 15 thousandths on there. So to me, that's close enough because I don't want to just blow it up for no reason.
I had 20 thousandths on that Buick, and that was like a whole big deal because they're normally, I want to say they're normally 40 to 60 thousandths in the hole, and then you throw a 40 to 60 thousandths head gasket on there, so it takes them from 80 to 120, and only the big block Buick and then the early 300s and the 215 has quench pads in the cylinder head. The rest of them are what they call a semi-hemispherical chamber. So it's just actually an open dome chamber.
Yeah.
So I don't really deal with it much on the 350 Buick, but on the early smaller cubic inch stuff and the big block, they have that quench area. I've never gotten them that tight because I'm not chasing that. Think about it. If you do, most of the tools that we as home builders use are from Harbor Freight. And if you look at the package from Harbor Freight, it'll say this, let's just say a dial caliper, right? This dial caliper will have 5 to 10 thousandths tolerance difference, right? And when you're talking getting it within 1,000th, you better be measuring with something serious, right? And I mean, I can't afford to eat an engine just because I got it too tight. Yeah. I don't put them that tight usually. Like I said, I got it within 20 thousandths, and I was pretty damn happy because most of the time they're about 120 thousandths. But it does make a big difference.
Tools. Yeah, I got good tools on mine, and I've got good dial indicators, and 15 thousandths is as close as I like to run. That's something that I have, and that's real because I can't take it apart every season to clean the carbons because carbon's going to add. Things are going to add. Heat expansion. Things are going to heat up and cool down at different rates. So I'm good with that.
What? And Danny Boyd's saying there, I'm a pessimist. Give me clearance. See, Dave Rear also said in his same interview about quench, when was the last time you heard an engine blow up from it being too loose? Okay, yeah. Loose, it generally means that they'll run for a long time sloppy and making all kind of rattling all kinds of noise, right?
If it's loose, no one knows.
If it's too tight, everyone knows.
That's right, and they know in a very extravagant way.
Yeah,
it's usually. Well, anyways, we're getting close, man. 4 minutes. Yeah. Anything you want to plug? Anything you got going on?
No. I'm trying to make it to tomorrow. Is about my biggest thing right now. Let's see. I don't want to talk about anything.
Okay.
I've lost 44 pounds from just stress. I'm about as I don't know, about as miserable as I've ever been.
Well, you're talking cars, so that's a good thing right now. It looks like we got a couple here. I was thinking here, one more scenario. I was thinking about avoiding platinum floor puddling and fuel washing when cold with either Edelbrock carb or single point EFI, unheated manifold, just add cylinder, heating up faster. Yeah, but on the slant 6, where mine's coming out at, there's so much heat there, almost instantly. It's barely. It's not going to puddle. It's not going to. At least I've never had an issue with that. I've ran it both ways. I ran with the exhaust going to it, the bottom of the carb, the manifold, and then the way I'm running it right now, and it's literally an extra minute, if that, and then it runs just fine. So I haven't noticed much. Brian Kaufman, 400-405 Mopar, torque flight.
He's got a stroker Mopar combo from a 400 block.
Okay.
TFS 270 heads, single plane 4150 with adapter to Dominator. Power still falling off at 6250.
Well, Cam. Bryce. Oh, this sounds familiar.
You know what? I've seen stuff. Okay, here's something, man. Yeah, it does. It's a good question. What cam? But what spring are you running?
I was just going to ask that because I was going to be the camshaft and I was going to ask spring rate.
I've seen them. I've seen the freaking spring essentially resonate before at certain frequencies, at certain RPMs. And what will happen is it can't make any more power until you get above that.
Yep. The frequencies match. Once the frequency of the cam opening and the spring they match, basically just doesn't work. And then you'll have a massive dip in power, and once you get past that, then it goes on. But Bryce, slantdailygarage@yahoo.com, slantdailygarage@yahoo.com. Send me your setup.
Hey, look at Tom Brown's thing here. He says, I have an old Starrett dial gauge from an auction that reads to the millionths.
What?
Have never found anything to even use it on, but it's cool.
That is awesome.
That is awesome. I mean, this is old mechanical stuff that would have had to be calibrated.
To the millions. Wow. I love Starrett. I have all the Starrett gauges. I just spend the money on it.
Danny Boyd's telling me not to sell my T-Bird. You can't really duplicate it. Yeah, you know what else I can't do? Race it anywhere. I built it for super gas, and everybody cried when it didn't have throttle stops on it. And they couldn't understand how I'm using EFI I'm using EFI to my advantage. No, I'm using EFI because I can run an entire weekend on a 5-gallon can of fuel.
Yeah. Bryce is saying that he's got my phone number. Dude, I'm telling you right now, I haven't been missing any phone calls. Huh. Anyways,
He's saying it's 305 spring pressure, 865 open.
Oh, so that's good.
That's a hell of a lot of spring pressure.
Well, yeah, but you need the spring pressure if it's up here it's showing 697, 705. There could be some things. But yeah, send it to my. You got my number then, so call me. Yeah. Oh, and he says he's got my dart trim. Awesome. Well, bitchin'. That's the front windshield trim. Well, anyways, we've hit 2 hours, man. That was a fast 2 hours. It was a fast 2 hours.
It went pretty quick.
Yeah, and it's good to have Dallas back. You're looking good.
I'm here. I'm just not fully back yet. I'm still partially on vacation.
But you're here.
I am here.
Anyways, but thanks again for coming by, guys. If there was a question that we didn't get to, once again, slantdailygarage@yahoo.com, slantdailygarage@yahoo.com, and for that, go and see Mr. John Wilburn on Friday night. He's going to have the numbers for the No Name Nationals, and we're getting down to time here. We got almost just over 2 months.
I'll be honest with you, I don't even know yet.
Yeah,
I'm so out of it.
It's 9:21.
My life has just been so chaotic. I don't even know anymore.
Oh. Okay, so he does have my number, so I'm going to write back to him. Yo, there you go. Got it.
All right. Well, we'll see you cats on the flip side next week.
Yeah, sounds good. You guys take it easy. Thanks for stopping by. You guys see you next week. Alrighty. You guys take it easy.
Thanks for all the well wishes.
Yeah. It's good to have you back, man. Alrighty. Later. And we